to the Math 107 Lesson 13 demo. We're going to start by graphing f of x equals x squared by hand. We actually just did this in the preview exercises, but just to remind you, you just make a little xy chart, and if you might know what x squared looks like, and if you don't, you just make a little xy chart. I'm going to go from -3 to 3 by integers. 9, 4, 1, 0, 1, 4, 9. Plot those points. Connect them with a nice smooth curve. And I've got the graph of f of x equals x squared. All right, so now I'm going to use some graphing technology, a calculator or GeoGebra, to graph x squared plus 3 and x squared minus 4. And I'm going to copy it onto this picture that I already drew. Okay, so I've got f graphed here in GeoGebra. Should look just like what we did by hand. Scale is similar, should look similar. Now I'm going to graph g of x equals x squared plus 3. So here's GeoGebra. G of x equals x squared plus 3. And I get this red graph, which looks just like f, but it's shifted up. And I'm going to copy this onto my other graph. I'm actually just going to take a picture of it when I'm done. So finally, I need to graph h of x equals x squared minus 4. And that looks like my original graph f, except I shifted it down. So I'm going to grab this and put it in here. Oops. Okay, I have replaced the picture we did by hand with the GeoGebra pictures of f, g, and h. So in our own words, we want to describe what happened to the original graph to get each of the new graphs. Has the graph been moved horizontally or vertically? So to get the graph of g, x squared plus 3, that's the red graph. And it looks like if I started with f to get to the red graph, I just moved everything up 3. So the graph of f of x shifts up 3. And to get the graph of h of x, if you start with f, you have to move everything down 4. Shifts down 4. Okay. So if I want to find f of 0, g of 0, and h of 0 to verify what f of 0 is 0. So that's f of x is x squared. G of 0, so this is g. If I replace this x with a 0, then you have to replace this x with a 0, so you get 3. And that makes sense because if I shift everything up 3, then a y-coordinate of 0 should become a y-coordinate of 3. And then for h of 0, if you replace x with a 0, you got to replace this x with a 0, so you get minus 4. And that also makes sense because a shift down 4 should take 0 to negative 4. Okay, we're going to check one more time, one more x value. Instead of 0, I'm going to check negative 2. Plug negative 2 into everything and make sure we have this shifting by 3 and by 4 relationship. So if I plug a negative 2 into f of x, which is x squared, right, then I get 4. Negative 2 squared is 4. If I put negative 2 into the g formula, I get 4 plus 3 is 7. And if I plug a negative 4 into the h formula, take negative 2 and square it, you get 4. 4 minus 4 is 0. So that relationship still holds, because if you are at 4 and then you shift everything up 3, you should land at 7. If you start at 4 and you shift everything down 4, you should land at 0. All right, so the domain and range of F, G, and H. So let's go look at my picture. It's a good way to do domain and range. So for F, my green graph here, F has a domain of -infinity to infinity, because these go to the left and to the right forever. So my domain's -infinity to infinity, but my range is just 0 to infinity, because when you're looking at the y values that this graph lives on, it doesn't ever go below the x-axis, so it's 0 to infinity. So let's see, my green graph, that's F, its domain is -infinity to infinity, and its range is 0 to infinity. And then G, that's my red graph. It also has a domain of -infinity to infinity, because those go left and right forever. Its range, the y value is where it lives, starts at 3 and then goes up forever. So 3 to infinity. And then H, which is my blue graph, domain -infinity to infinity, range -4 to infinity. Okay, has the transformation changed the domain? Nope. Nothing about the domains changed. But yes, we changed the range. From F to G, the range went from used to start at 0, now it starts at 3, which makes sense for a shift up 3 units, adding 3 to every y coordinate. And same for H. We have a change in the range of, instead of starting at 0, now we start at -4, which makes sense for a shift down 4 units. We subtracted 4 from every y coordinate. Rewrite G and H as transformations of F. Okay, so I know that the formula for G is x squared plus 3, but x squared is the formula for F. So I could replace x squared with an f of x, because f of x equals x squared. So I'm just going to make a little substitution here. So this becomes f of x plus 3. And h of x can be written as f of x minus 4. We want to apply the transformation to a few points on F. Find corresponding points on the transformed function G. So any point on F, to get the corresponding point on G, you just add 3 to the y value, because that's what the transformation says to do, right? G of x is f of x plus 3, so you add 3 to every y, and then you get a corresponding point on the new graph. So -2, 4 becomes -2, 7. -1, 1 becomes -1, 4. And then we have 0, 3, 1, 4, and 2, 7. All right, that concludes the demo for lesson 13.